This video will introduce the concept of functions. And be sure to see the video following this that will talk about function notation. A function is a mapping such that each input maps to only one output. We want to be able to identify functions when we see them on graphs or in tables or with a formula. If we're given a graph, to identify if it is a function, we want to find if it passes the vertical line test. If we're given a formula, we say that b is a function of a if we can solve the formula uniquely for b. If you solve for b and you get 2 or more answers, then b is not a function of a. If we're given a table of values and we want to find out if b is a function of a, remember that you'll have your b as your output, your a as your input, and if you can look at the table and each input a maps to only one output b every single time, then that means b is a function of a. So let's look at several examples of this and see if we can sort that out. In the first example, we're given a table of values. We have input x and we have output y, and we want to know if y is a function of x. In order for y to be a function of x, we should be able to pick any input, for example 7, and we will be able to know exactly where it maps. So when x equals 7, can you look at the table and know exactly where it is mapped to, which output? Well, in the table it looks like 7 maps to y equals 6. And if you go down the table further, I see 7 occurs again. But again, it still maps to y equals 6. So if x equals 7, then y equals 6. Same thing occurs for every other x value. If x equals 8, then y equals 5. If x equals 10, then y equals 4. Let me see that again down here. And if x equals 12, there's only one y value it maps to, 15. So in this case, yes, each x value maps to one unique y value. You know exactly where each x value is mapped to one specific y. So y is a function of x. In the next example, again, we're given an input-output table. We're inputting x, we're outputting y. And again, we want to know, is y a function of x? Again, notice in the table, when x equals 7, it maps to y equals 6. And we see that again down here. When x equals 7, y equals 6. And in the table, when x equals 8, y equals 5. And again, it's repeated down here. When x equals 8, y equals 5. However, we have a problem here. When x equals 10, we have 2 different possibilities of what could happen. We could have y equals 4, or we could have y equals 20. So x equals 10 does not map to one unique y value. X equals 10 maps to 2 different y values. So since x equals 10 maps to 2 different y values, you cannot say that each x maps to one unique y value. So y is not a function of x. Now, suppose we're given a graph and we're asked, is y a function of x? Again, y is on the vertical axis, so y is the output. X is on the horizontal axis, so it's the input. And looking at a graph is quite simple to determine if it's a function. All you have to do is take a vertical line, like so, and move it across the graph, and if it intersects the graph only one point at a time, you know that y is a function of x. So if you imagine a vertical line moving across this graph, it would only hit the graph one point at a time. So here clearly it passes the vertical line test. So y is a function of x. And in the next example, if you just glance at this graph, you can clearly see it fails the vertical line test. If I take a vertical line and pass it through right here, it would intersect the graph in 3 different places. So it fails the vertical line test. So we conclude, in this case, y is not a function of x. The third thing we want to be able to do to identify if it is a function or not is be able to look at a formula and determine if y is a function of x. In a formula, if y is a function of x, then you can solve the equation uniquely for y. Now, in this first example here, we're given y equals 3x plus 1. This is already solved uniquely for y. It tells us y is 3x plus 1. You pick an x, you plug it in here, you take 3 times that x value, add 1, you get the y value. So this is solved uniquely for y already. Therefore, we conclude y is a function of x. The second example, the formula is not solved for y, but I certainly can solve it for y. I can take this formula, I can subtract 2x on both sides, so that I have 3y equals negative 2x plus 12. Divide both sides by 3 in order to get y alone. And now I have y equals negative 2/3 x plus 12 over 3, which is 4. So now I've rewritten the equation so that I have solved for y. And I clearly see there's only one answer. Y is negative 2/3 x plus 4. One expression that y is equal to. Again, since I can solve uniquely for y, I know that y is a function of x. In this formula, if I want to determine if y is a function of x, I'm going to try to solve the equation for y. If I have a unique answer, y equals one thing, then I know y is a function of x. If I get more than one answer, then I know y is not a function of x. All right, so I'm going to go ahead and solve this equation for y. I'm going to add 16x squared on both sides. So now I have 9y squared equals 16x squared. Divide both sides by 9. Now I have y squared equals 16x squared over 9. To get the equation solved for y, I need to take the square root of the left side and the square root of the right side. The square root of y squared, the square root and the square cancel, leaving just y. And on the right side, I have to take the square root of all of this. That'll be the square root of 16, which is 4, square root of x squared, which is x, and square root of 9, which is 3. However, you got to be a little careful here, because really when you take a square root, there are 2 answers always. Here we have y squared equals this expression. It could be that you had a positive y value being squared to equal that, or a negative y value being squared to equal that. So when you took that square root of both sides, we have to remember to put a plus minus out front. What this tells us is that the y could be 4x over 3, or the y could be negative 4x over 3. And so in this problem, we have 2 answers for what y could be. Since we're getting 2 different answers out for y, we know that y is not a function of x in this situation.